The following content has been provided by RWTH Aachen University.
All right, folks, welcome back to iOS application development. We are currently in the middle of picking up the remaining pieces of the Swift programming language. So we'll get into a couple of more advanced things there. And we will also talk about a few more things regarding, of course, UIKit, the frameworks that you're going to be using, and how to build interfaces with UIKit and Xcode. So let's start with a quick recap here, see if everybody still remembers these things. We did talk about optionals. So what's an optional? What does it do? Yeah, go ahead.
I think these were variables that also can contain nil,
Mm-hmm.
also normal value.
Mm-hmm.
You have different options like to get the value out of the variable.
Right. So the optional one is named that way because it is optional to actually have a valid value in there, right? It could also be nil. Normal variables cannot be nil in Swift, just for safety. And there was a lot of discussion around that, right? Remember how you specify an optional? How would you create like an optional int? Yeah, go ahead. Yeah, with a question mark, right? So question mark and exclamation mark are your friends when you're working with optionals. So keep that in mind. We did talk about a whole bunch of things, right? So what does the exclamation mark do when I put that behind a variable name? Yeah? Is that a good idea? Exactly. So putting the exclamation mark behind it unwraps it, and usually this can be a good idea, but like you said, you really have to know that you're doing the right thing, right? Maybe the line before literally sets the value of this thing, right? Then it's, of course, it's safe. If you're not 100% sure, what's the safe way to unwrap an optional? Yeah?
I'm not 100% sure, but I think it was like with an if statement, you should first check if it's nil, and if it's not, then you unwrap it. If it's nil, then you leave it like this.
Exactly. So you put this in an if statement. Of course, like basic programming practice, I check, is it nil? If so, then I have to do something special. Otherwise, I can assign the value to a regular value and then do the force unwrap. Now, because that happens so often, there is a nice way to do that in Swift. What's the statement that it reads a little weird? Yeah, go ahead. The guard statement is one option actually, but there's an even simpler one if all you want to do is just unwrap a single value. If let, exactly, right? So if let basically is just shorthand for if it's nil, then, or if it is not nil, then do the following. And you're right, the guard statement is of course another option of doing that. It's kind of shorthand for nested conditions, right? Where you basically say, oh, I have to check for all these different things, and rather than creating this deeply nested, if-let sequence, you can actually use. And if the first condition doesn't hit, then there is a special thing you need to do. What's one of the requirements of guard that's a little, puts a little bit of extra structure in your code, requires you to do something that you wouldn't otherwise? Yeah. Yeah. Yeah, you have to do something like break out of the, basically you have to somehow leave the inner range, the domain or loop, whatever it is, to get out of that. Exactly. Now, do you guys remember how you would, if you have lots of if-lets, then yes, one way to do that is guard, but there's another way to do that? Yeah? Yeah, you can use commas to have, if you have multiple variables that you want to test, absolutely. But if you have the case like, you want to look into one, and then if that's not nil, then I'm going to use that, and, yeah, go ahead. Exactly, lots of optional chaining, right? You get lots question mark dot, and you'll see that, in Swift code quite regularly. Okay, so another thing we talked about was typecasting and inspection. So what does as do, as question mark? You may recall that, yeah?
It tries to cast it and fails, returns nil.
Yeah, right. So that's a casting into a subclass. Like you say, you have a general class, and you want to, you want to test. It's probably going to be of some subclass, like vehicle versus car or something, right? And if you want to turn it into a car because there are some things you want to do with it that only the car subclass supports, so you can do that. And if it isn't, then you do get an optional back. Now, is there another way to do that? A less safe way? As question mark is the safe way to do it. Of course, the unsafe one is the one with exclamation mark, right? Yeah, sorry. So as exclamation mark would actually do the just hard subclass cast your or downcast if you want to the subclass, and you can only do that if you're really sure that the subclass is correct. All right. We did talk about guard already. And you have to leave the scope. That was the word I was missing earlier on. And we talked about enumerations. So we introduced enumerations. So they're not, basically they exist in other programming languages, right? Why do you use enumerations in other languages or in Swift? Why would you do that as a good coder? Yeah.
If we have, for example, I think it was the example of the last lecture, the genre of a movie, you don't want to have any input, so you can create an enumeration, and then you have like only the words that you previously defined possible as the genre.
Right. So the key thing, and that's what we often want to do, so we want to move bad stuff to happen to us earlier rather than later, right? You want, for example, in the enumeration, I could have the string stored as a kind of movie, but then if the user, if something happens in my code that assigns a kind of movie that I actually haven't covered, then things blow up at runtime. So if you do this in enumeration, there is no way that your code will compile if it somehow tries to assign something to it that isn't in the enumeration. Right? The compiler will check for whether your assignments are one of the valid values already. So that's just good programming practice. What else did we talk about with enums? Let's see here. Yeah, so type safety is one thing, right? It's safer. The other thing with enums is, of course, that they do what? Or the usability chair here? Yeah? Yeah, they do increase the readability, right? It's just easier to read if you have these enums spelled out rather than using like 1 for north and 2 for east and 3 for south or something like if you have a compass app. Okay, now moving from Swift language features to actual things that we looked at in Xcode and the way that you build your interface. Do you guys remember what a segue is? Other than it's these cool two-wheeled things that you whiz around on in the city. Yeah.
A transition, I would say. Between the storyboard, like of one screen to another screen.
Exactly. So typically your mobile apps will consist of multiple screens that you move between, and the segue is this transition between those screens. We took a little bit of a look at that, and you also saw the navigation controller. Right? So what is a navigation controller? Yeah.
You could even have top bar layout or button top layout where you can navigate between those views very easily.
Yeah. So no matter what kind of layout it is, you're right, it can have different looks, but it does basically give you, it contains several view controllers, right, of these individual screens, and adds a navigation bar of some sort. Right? And we also saw the tab bar controller as a variant of that at the end of the last class. All right. So we're first going to take a little bit of a closer look at the view controller. You may remember the model view controller paradigm that we talked about last time. If you are shaky on MVC, if that's something that you haven't heard a lot about in your previous classes for some reason, do take a look at the book. It actually has a fairly good section on really laying it out for you why MVC is like the design pattern that object-oriented programming uses pretty much the most, probably of all, the most famous one. And how, in particular, there's lots of different flavors of MVC too, and you'll each time you use MVC or you find it used in a framework or in an app, it will maybe look a bit different. And Apple's UIKit has a particular flavor of MVC, if you want, where the view controller is sort of in the middle. That the controller is strongly in the middle of the model. And read up on that in the book if you're shaky on MVC. Now, UIKit contains a special kind of class that controls a view, right? So if you have model view and controller the controller is supposed to do something with the view, then there is a special class for that. And it controls the views. It sets up any children, so child views that a view may have, right? For example, you may have a dialog with stuff, multiple things in it, buttons and whatnots and scroll bars, text fields, etc. So it would take care of that setup for child views. It also controls what they actually display, and it responds, and that's probably maybe in an user interface way the most important one. It's the one that responds to user actions. Right? Anything that the user does is being dealt with in the view controller. So the class name for that, the general class name for that is UI view controller. And you may remember, if you know MVC, there is this idea that the model is something that is really specific to your domain. Let's say you're modeling, whatever, how a car, simulation works, simulating a car, all the details of how a car works. But you could basically glue any interface onto that, right? That's the idea. All the interface independent stuff, the UI independent stuff is in the model, right? So that kind of can stay static across different apps. If you build one that's a 3D simulation, the next one is like a little 2D game, and could all use the same model of the car. The view, on the other hand, is the user interface, of course. Now, the user interface as a whole keeps changing, but a lot of what's in the user interface is actually standard components, right? Buttons, sliders, scroll bars, etc. Now, so these, from a sort of vocabulary of widgets, also tend to stay the same as long as you're building standard, productivity apps that use the standard UI kit. Now, if you build, an immersive app or something that needs a very custom interface, different story. But usually, if you build, plain old productivity apps that look familiar to the user, they know how to deal with them, you will be using existing stuff from the UI toolkit. In this case, UIKit. So if somebody gives you a model and you've got UIKit, what's left to do? Well, what's left to do mostly, and what's really specific to pretty much every app that you build, is the controller class. That's the glue between your view and your model that specifies how everything hooks together. So you will often be writing custom controllers by subclassing the UI view controller. So most commonly, what we have is we've got an app. It has multiple screens, right? You want the user to be able to move from one to another. Now, each screen in the app is represented by a scene in the storyboard that you've seen in when you build your interface, right? You lay it out in the storyboard. I should say that this is the UIKit way of doing things. Swift UI, things will look a little differently, right, when we get to that. But in UIKit, it's on the storyboard. And each scene in the storyboard itself is then, again, associated with a subclass of UI view controller. Okay, so to get so the real app, what's on what you see in the UI design tool, and what you actually have in code to make those link together. And this associated UI view controller class that you create, the subclass rather, is actually something that you would typically specify in a separate Swift file, right, in a .swift file. And that basically contains all the logic that this scene requires, right? This screen in your app requires. And each UI view controller class also has a view property, which actually is the view that it controls, obviously, and it's also it has a view property that represents the parent of where that scene is being hooked into. Like you said earlier, we've got a navigation controller with multiple things, and it needs to have all these children stored. So you'd have a pointer back to your parent so that you can get back to that. So typically, each different type of screen that you might see in an app is managed by a different type of view controller too. So we'll talk a little bit about life cycles now, both for view controllers, and then later we'll get into life cycles for your entire app. First of all, let's talk about the view controller life cycle. What does that mean? Well, when you launch an app, not all of its screens are visible, right? Only one is visible. So at some point, a screen will come to life and be there and be instantiated and be the thing that the user interacts with. So let's look at what happens there. A view controller can be in any of the following states. It cannot be, it cannot be loaded, and as long as it's not loaded, there isn't much you can do with it, obviously. Next up, it then, it has been loaded, but hasn't appeared yet. This is something where you might actually want to do something, right? In fact, view did load is a method that will get called where you can provide custom functionality at this point when you know the view has been loaded into memory, but it's not on screen yet. So this is where you, for example, might initialize any objects that your view controller might need, because then next what will happen is that view will appear will get called, and then the view actually appears, and then view did appear gets called. This again, just on a meta level here, this is a pattern you will see again and again in UIKit. That you often have these hooks provided to you, the application developer, right before and right after something happens. And that's there for you to take on certain, to implement certain custom functionality that you want to happen at that time. All right, so when the view has then at some point appeared, that means that its bounds are being defined, but orientation isn't yet set. But once it has become visible, then of course everything has been done. And this is at the point when the view did appear. That's when you're basically, this is where most of the stuff actually happens, right? At that point, where the user interacts with your view, does stuff to it. You may run any animations, you may respond to user input, etc. Now at some point then, what you will get is that the view disappears. Maybe, why would the view disappear? What are some reasons for that happening? What do you think? Yeah? Yeah, I might be navigating to another view. Can you think of a reason why it would disappear when you're not doing anything as a user? Yeah?
The phone might come out and lock.
Yeah, maybe your phone locks, or maybe a phone call comes in and puts this thing, this modal thing in front of you saying like incoming call from your mom, right? You need to take that. You can no longer use the app. So there's a bunch of reasons for that to happen. So, and this is when things get a little dicey. When your view disappears, you need to be aware of that. You need to make sure to save as much as possible of what was going on right before that happened. Right? That's why this is important. View will disappear. Like, we're about to disappear, Then you want to hook in and say, let me save any state so I don't lose data. Maybe the user typed in something into a text field, started typing in the name, and then the phone call came in. When the phone call is finished, they might want to retrieve those things. Yeah?
Should you do that in will it disappear or did disappear? Because like from a user perspective, if I'm just do the home gesture to go home,
Yeah.
and now it starts saving a lot of data,
Yeah.
Wouldn't it be smarter to do that in the did disappear when it's already in the background?
Not a big deal. I mean, the one thing that might be tricky is the moment you enter did disappear, things you could also get purged very quickly, right? Because maybe memory is tight or the user kills the app or something. So if there's anything that you must do, I'd rather do it in will disappear, because then you're like, no, wait, I still have to do this thing, right? So you can put that in there. Now when it did disappear, that doesn't mean that's the end of it, right? Of course it can come back, right? If the user goes back to the screen or the phone call ends or whatever, then you will obviously have that come back to you. So that's a bit to give you a feel for what happens with individual views and the view controllers. Now let's look at what the application lifecycle is. And notice that all these things are called view did this and this and this, but they're all actually things that define the state of the view controller, right? Now we have the whole application lifecycle that states basically that defines what state your app is in. And here is something interesting that has been going on recently-ish, because it used to be that you only had to think about your app lifecycle as a whole, right? Your app was either in the foreground or it wasn't, right? This has changed. As you can see on the screen, you can probably guess why that has changed, right? It's, of course, the multi-tasking that has been making its way into, especially, interfaces on the iPad. iPad OS supports multitasking for a while now. And as you can see here, we've got one iPad, and it's running 2 instances of Safari, right? On a desktop, we would call those windows. But they're not really windows, right? They don't have any window decoration. They don't have close buttons or anything like that. It doesn't quite look like a window on a desktop. It is more like tiles on a full screen view, right? They can't overlap, at least not there yet. Even that is now coming, as we know. But so what we need to distinguish real quick is you used to only think about your application lifecycle. Now you need to actually think about scene lifecycle, because these individual things are called scenes. And that's why your file, if you don't have to do this, but if you opt into using scenes, if you say, I want to be able to have the user possibly run 2 instances of myself running next to each other or something like that, then you opt in and implement the scene functionality. And if you do that, then you will end up with 2 delegate classes. We'll talk about what delegates are as a design pattern in a moment. But for now, there's an app delegate, which always used to be there ever since UIKit existed. And that's the one that is responsible for the whole application. And then there is a scene delegate, which is responsible for these individual instances of your app running. And if you do adopt the scene idea, if you make your app able to do this multitasking with multiple instances, then most of these interesting changes will actually be happening in the scene delegate, right? Because every individual scene, even if there's only one, it's a scene, and all these foreground, background things will be happening there. If you don't adopt it, you'll stay with the corresponding calls for the app in the app delegate. Now, what are things that why should you be interested in whether your app is currently, or your scene is currently in the foreground or background? Well, in the foreground, you got all the CPU power that you want, right? You can, if you're implementing a game, this is where everything can happen. But if you do get moved to the background, you should really let go of those resources, right? You don't want your expensive, 3D simulation engine keep running in the background, even though you're not even visible, draining the phone's battery while somebody is checking their mail or something like this. Right? So it's really important to know whether you are in the foreground or the background. So in the background, you're basically supposed to be doing as little as you can. As of course makes sense for the application. Some things need to do stuff in the background to be useful. Like if I have something that is supposed to alert me when I arrive at a certain location, that app won't always be in the foreground probably, so this may require background processing. All right, so let's look at the app delegate here first. And as you can see, the app delegate, I highlighted the things that are interesting here. These are the various, again, calls that you can hook into, similar to how the UI view controller had these calls. This hooks when you want to react to certain things happening. Right? This did finish launching with options. Basically, is one of the first opportunities for you to actually run your own code. Then, if you get this configuration for connecting, is to pick a configuration to create the scene with. And then finally, did discard scene sessions down here basically is called when the user discards a scene session. In this multiple multitasking interface, if I remove one of those 2 panes of Safari, for example, then that would get called. Okay, so this is something, for example, if you had if this happens, then you would throw away anything that was specific to that scene, because that scene will not come back. People might create a new one, but this one is gone then. In fact, when you basically just adopt this idea of supporting scenes, a lot of it, if you ever end up doing this, will actually get provided to you by the framework. So often you won't be having to deal with these a lot, and usually stuff gets defaulted for in useful ways for you by UIKit and the compiler. So if you don't use scenes, this is basically, we can think about this as the app lifecycle, but if you do use scenes, then it's the scene lifecycle, right? Just to be clear here. Unattached means it hasn't been launched or it was terminated. We're up here in this sort of starting state. So when basically then from here on you might move to the foreground or to the background, right? If the user requests a scene, then you're in the foreground. But if a system requests a scene, you may actually end up being in the background over here. Now, if you are in this background inactive, this is really just foreground inactive. This is really just a transition state. That's when you're not receiving touch events yet. Usually that only happens as you're launching, for example, right? And then once things are running, we're in this foreground active state. Then if the user moves to a different app or moves back to the home screen or stuff like this happens, you are still running in the background, but not visible, right? So the user may have triggered this, or that famous phone call came in, and there is a brief period of time here then where you do get suspended, and that would be this like will disappear, similar to the will disappear that we just talked about, where you can then save important information. And from there on, you are in the background, and here you, when you're suspended, then there's no longer anything that you can do. So again, these are the hooks that you will find in your scene. Will connect to is basically the method to maybe configure and attach the UI window to the corresponding scene, for example. If you use a storyboard, the window property will always be initialized automatically to the scene, so you don't need to worry about this. This is another example, of course, of these delegate methods that are hooks that you can jump in to do something to. There is the scene did disconnect, which gets called as the scene is being released by the system, which happens right after the scene enters the background or when the session is being discarded. So you throw away any associated resources at this point that you can recreate the next time the scene connects. In the scene did become active, of course, you can restart any tasks that were paused or that haven't started yet when the scene was inactive. Resigning active gets called when the scene moves from an active state to an inactive one, like with these temporary interruptions that we mentioned, like the phone calls. And will enter foreground is something that gets called as it transitions from the background to the foreground. So you would call this to undo any of those changes that happened when you entered the background. This looks like a lot of stupid housekeeping, but you've probably noticed this when using maybe an iOS device at some point. Sometimes you start doing something in a screen and something happens. Like you may be entering, I don't know, your user information in a text field, let's say, and then you're like, oh, let me quickly go over to my whatever password manager or this other page where I wrote this down, or my note. And most of the times this works, right? You do this and you come back, and what you filled in is still there. That's when people did a good job with all these calls and hooks. But I've seen cases, sometimes even Apple's own implemented things. You have a URL, you say share this URL to an email window pops up. He's like nodding. You know what I'm talking about, right? You start typing that email. It turns out to be a little longer than you thought. It's not just a link. You want to include a couple things, and you're like, oh, by the way, I wanted to invite this guy over, for a coffee. And you hop over to your calendar to check when this could be a good time. You come back, and this whole pane is gone. Right? That sometimes happens. So that's when all these tricky background, foreground things and saving state as you get swapped out and back in don't work out so well. So these are things that you definitely want to avoid. do a good round of testing on your app to see if all these cases where people get whisked out of your app, whether it's by themselves or by some external event, whether that restores nicely back to the state that you were in when your app comes back into the foreground. All right. We'll do a quick demo next, because what we're going to talk about now is auto layout. So do you want to start setting up maybe? Because so far you've mostly dragged UI components into your canvas, right? And maybe they look great. Maybe you let them snap to something that your Xcode was providing, but maybe you didn't. And so we'll talk about what does UIKit provide in order for UI components to actually be arranged nicely on your screen. And that's not just a static question of laying it out at the first start. I mean, first of all, of course, you need to think about that the phone that your app is running on could be a tiny little old iPhone with a touch home button still, with a tiny little rectangular screen, or it could be a Pro Max monster, like pocket bulging monstrosity. And so all of these different sizes are available, right? Or it could be on an iPad actually, if you're supporting that device. Secondly, people could turn it sideways, or they could be running it in portrait mode. So again, completely different story. And somehow you need to define as a developer what should be happening to your UI. Right? Where should buttons go? Should they resize? Should they scale? Should they move? And auto layout is what helps you really do this nicely. And if you do a good job with your auto layout, then your UI will always look very polished, no matter what screen size it's running on, what orientation the screen is at. Whether it's maybe running in split screen, for example. Split screen creates a whole new kind of aspect ratio and size class, really, that again, apps need to be able to support. So there's no way that you can specify all these cases by hand unless you want to go crazy. So auto layout is your friend. Last section of today's class is just going to be a bit more Swift, a bit more language stuff. But this is not unrelated to UIKit, because you will find the concepts that we talk about now being used extensively in the framework. So I just wanted to lay them out for you so that you know what they mean on a language basis. First up, protocols. Protocols are things that you probably know from Java. They are blueprints of methods, properties, and maybe other requirements. And basically, if your type adopts a protocol, that means that you need to implement these requirements. So for the Java folks out there, what does that relate to in Java? What's the corresponding feature in Java? Yeah. Interfaces, exactly. So we're talking about interfaces here. So protocols are just, if you haven't used them much in Java, maybe they're like a contract, right? That you need to fulfill if you say, I'm adopting, as we say, I'm adopting a protocol. However, you are probably used to protocols from classes, right? Classes adhering to protocols. You can, in Swift, use protocols also on structs. Like I said, structs are getting a big boost in Swift as data structures, and you can even use them on other things like, for example, enums. Even there, you can use protocols. And what we're going to do is we're going to go through 3 examples here of protocols, just to really drive it home that this is a very common thing that is being used. It's a language feature, but it's also a design pattern in the UI kit and in iOS as a whole. That is used very, very frequently. Let's look at these 3 examples. The first one, custom string convertible, is a simple protocol that solves a very well-known problem. You probably know this from Java, right? I can print out a string, that's easy. I can print out an integer. I can print out a Boolean, and they all have their sort of screen representation. But what if I define my own custom type? How is that supposed to look on screen, right? I need to somehow, if I have my own class or my own struct that I defined, my own type, how is that going to appear on screen? So the solution to that is basically just to say, well, I have a class here. This is a shoe class that has color, size, and it has laces Boolean, and it has an initializer that sets these things. And if I now want to go ahead and print that out as a custom class, that won't work, right? So this is not the solution yet, this is the problem, right? Because if I do actually set up two shoes, like my shoe and your shoe here, and then print them out, I get like LLDB expression 143. Not so great, right, as a description of what that instance is actually about. So how we solve this is by adhering to a protocol. And the protocol in this case is called custom string convertible, meaning I say that my shoe class actually adheres to the protocol, custom string convertible. That's the first thing I need to do. So I basically put that there. It looks like I'm subclassing, doesn't it? With the colon and everything. And I'm going to get back to that later, why it looks like subclassing. But it is not subclassing. You could actually do this with struct as well. You can put struct here. Everything's going to work just the same. And so when I do this, I've done one part of the deal. The other thing is, of course, when I say, OK, I'm adhering to the protocol, custom string convertible, then I need to do something to actually fulfill that protocol. And that, in this case, depends on the protocol, of course, is I need to implement, I need to have a property called description here, or a variable, I should say. And that variable basically here gets set and returns, as you can see, something that says color, shoes, blah, 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 blah. So it assembles something from the existing properties up there to basically return a useful string, right? So it's not a property, it's actually a computed property, as you can see, right? Because I'm giving you, after the type, I'm giving you a little bit of code that says how to set the value of that type. Now, if I do this, if I have this description defined, this code actually runs fine, right? I can actually print my shoe, print your shoe, and it's going to use this description because we are adhering to the custom string convertible protocol. We get a proper output because it uses the description string that's being computed here to return something that works fine. All right, example number 2, equatable. Let's assume real quick you're building an employee database, right? And this thing has a data structure called employee with these properties here. And of course, one of the things that you need to at some point use in your database is when are two employees equal, right? Very simple problem. Maybe you want to remove duplicates, or maybe you want to make sure that somebody can only edit their own record and not somebody else's. So you need to compare two employees to each other. As you know from Java, and this is just here true for structs as well, as you can see, this won't fly. You cannot just say employee B equal employee A if you created these two as employee structs. This doesn't work because Swift won't let you do this. So whenever you create a custom struct or a custom class or anything like that, a custom data type, you don't have equality defined by default. But there's actually not that much you need to do. What you need, if you did it this way, you would get actually a binary operator, equals cannot be applied to employee operands. If you, however, adopt the protocol equatable, again, just like that, then things work out. What do you need to do to adopt the protocol? Well, you need to implement one function, right? That's the requirement of the protocol. It says there needs to be a function. You need to basically define what equals means, right? So you're redefining you're defining the equals operator here in this case. And when you do that, things are fine, right? So once I put that in this case, by the way, my version of the equals here just compares first name and last name. And I say, if first name and last name are the same, even if they have different job titles or different phone numbers, it's probably the same person. It's kind of a sketchy assumption, but let's say that's true. Then you can say, OK, I'm going to merge these database records, for example, right? I mean, I do this all the time in my context database. I've got people in there with multiple phone numbers, and it's actually the same person, so I need to just merge it into one contact. So that's easy enough, right? So if employee B equals employee A, this works fine now at this point. If you, however, decide, no, I actually want these two structs only to be considered equal if all things differ. Maybe you've got a big company, so names are probably going to come up in duplicates. Two people are going to be called Bob Jones, you know, and maybe only their job title differs, but they're actually, you know, different people. Or maybe you actually have two people who have the same job title, but not just the phone number is different. They're actually different people. So if that is the case, you're going to say, well, my equal should only really return true if all the constituent properties here, of all these properties, are the same. That sounds like a lot of work, right? You need to write like a really long, you know, custom static function. Except, hey, this is Swift. You don't have to do that. Right? If all of your properties need to be the same for equals to return true, then you don't need to do anything at all, because then Swift will actually generate, auto-generate this equals operator for you. It will by default assume that it just needs everything, you know, all the components here to be the same for the whole struct to be the same. This works for structs, this works for enums, but it doesn't work for classes. That's one limitation that you need to be aware of. So the auto-generation part doesn't work that way. Also, and that's kind of obvious, of course Swift needs to know how to determine if these individual things are equal. Right? So these need to conform to the equatable protocol. But you know, the built-in types like strings and ints and stuff all do that, of course. So that's equatable, example number 2. Example number 3 is comparable or comparable. So the idea here is maybe we want to sort our employee data list, right? So we've got our employees, and now how do we sort them? Maybe we want to sort by last name. Right? Currently, we can't do that because, again, it's a custom data type, and we haven't told Swift what we mean by, you know, this one is bigger than this other one. We haven't defined a relationship of that sort. So if you try to sort them, which, you know, as a cool kid, of course, you would not write a sorting algorithm, right? You'd just say, let sorted employees equal employees dot sorted, and then say by the less than operator, right? Because that is possible in Swift. But it wouldn't work with this custom data structure because we haven't told Swift what less than means. And again, we can fix that. We adopt the comparable protocol. Now, to adopt the comparable protocol means that, you know, Swift then knows I can actually compare two instances of this data type. What do you need to do for this? First of all, you need to also support the equatable protocol. So we're putting that there as well, or we leave it there rather. We add comparable to it. The second thing you need to do is you need to now also, apart from the equals function, which you need to do because of the equatable protocol, you need to provide a less than function. Right? The less than operator needs to be defined. And here, you know, this is a stupid implementation. It just basically says, you know, one is less than the other if the one name is less than the other. You probably want something a little smarter in there, right? You know, if the names are the same, then maybe go by first name and do the order that way, so that, you know, Bob Jones comes before, you know, Philip Jones, for example. But you know, that's just an example here. And again, Swift is nice, so you don't have to implement the bigger than and the, you know, unequal operator and all these kinds of things, or less than or equal. All those Swift automatically derives, right? So you don't have to implement these. At this point, when you do that, you could write code like this, you know, just as before, sort them by less than, and that would work just fine. You could also say sort by bigger than, even though you haven't specified what that means. Swift figures it out because, I mean, it's obvious, right? So protocols seem like a useful thing. Yeah, go ahead.
With comparable and the order generation, by which type do they sort? Because we have 4 different variables. Does it just sort by the first one or compares all?
I didn't say anything about auto-generated by with comparable, just for equal. Yeah, for equal it does that. So another protocol that is super useful is codable. Codable is something that you use, for example, you'll all have to save data at some point, right, of your app to some file or whatever. You need to basically put it into some JSON format, for example, right? That's usually a necessary thing to do. And in order to do that, you can basically make sure that your data structure adheres to the codable protocol. And if it does that, and there are things that you need to do for that, But for all the built-in data types, again, codable is defined. So oftentimes it's just enough to say, hey, I'm codable, and then all the properties are hopefully, simple data types that already support that, and you're done. You can basically run a JSON encoder on the stuff and write it out to a text file, for example. What's the principle in Java that I'm talking about here? What is that called in Java? Sure, you've saved stuff to a file at some point. Yeah. Yeah, well, JSON encode is the thing that you then use to do that. Yeah, but what is the interface basically in Java? Yeah. Yes, it's serialization. Exactly right. So if you're serializable, then that basically means that the same thing in Java. You can tell I taught a Java class a long time ago. Now, you might want to create your own protocol as well, right? So how do you create a protocol? This actually is an example for a protocol called fully named. Whatever we might want to apply that to, maybe we've got a person record with first names and last names, and we want to make sure that the person is under certain conditions. I want them to adhere to the fully named protocol. So they need to have a first name, they need to have a last name, and if they do, then I can actually also provide something like say the full name, right? Write it out, put it out on the console. So this looks a lot like a type definition of a struct or a class or enum, doesn't it? This looks basically like a struct, for example. But there's a couple things that are different. I mean, you do specify what kind of methods and properties you want to be there. Like here, we want a property full name, and we want a method say full name. But there's something weird in here, right? There's this get in there. What does that mean? Well, this specifies inside the protocol whether the property that you're adding to the protocol is supposed to be in a read-only variable or a read and write, readable and writable variable. Right? So if you have get in there, then it's a read-only. If you have get set in there, both words, then it's read and write. Let's see here. Yeah, here's an example of then using this. Right? So I've got my protocol defined up there. And now here's our struct, or person struct that we've used before. It has the first name and last name, and it also adheres to the protocol fully named. Right? That's what we're claiming here. So in order to do that, again, it's a contract that needs to be fulfilled. We are providing both the computed property var full name. Right? This one didn't say how that works. Right? It might be anything, but in our case, we just return basically first name and last name one after the other with a space between them. And then we have a function called say full name that we also need to implement because the protocol asks for it. And we just basically print the full name string out in this case. So if you don't do this, if you don't have these things fulfilled, if you say, oh, I could adhere to the fully named protocol, but you don't actually implement all these things, then your code will not build. Right? So fulfilling a proper protocol is required for your code to compile. And now back to the thing that we talked about earlier, that protocols actually look very much like a subclass, right? With this colon thing here. The reason behind that is that both subclassing and protocols are a way for adopting shared functionalities or properties. When you subclass, that's what you do, right? You subclass a bunch of things. They all have the shared superclass properties and methods available to them. And protocols also mean that whoever fulfills a protocol, however they work internally, I know that they all share the following properties and functionalities. In fact, this is for an advanced topic that we'll get back to later. You can actually even provide a default implementation inside a Swift protocol. So you can even put something into a protocol that says, I need you to adhere to that, but in case you don't implement it, here's what I will return by default. So that's really becoming almost like a superclass thing here. All right, now this is a language feature used extensively in UIKit and in iOS. Now onto a design pattern that I actually mentioned this earlier on when we started out. and this is delegation. Delegation is a design pattern that lets you hand off or delegate responsibilities to an instance of another type. Who has seen delegation before? You just raise your hand. Delegates, delegation mean anything? Okay, not really much. Good. So it's a really important design pattern. It's all over, iOS. In fact, this is not a language-specific feature. You could do delegation in any object-oriented language. It's really just a design pattern, a convention, if you like, how you structure your code, your classes, how they connect to each other, and how they talk to each other, and how they use each other and call each other. So UIKit and other iOS frameworks use this all over the place. In fact, when you go back, if you look at our class Designing Interactive Systems 2, where we've always given a little bit of an introduction to iOS, very, very compressed. Even before Swift was out, we were talking about Objective-C, delegation was already there. Right? It's not language specific. So delegation is a quality really more of the APIs and the classes that you get provided by the framework, quality of the framework, not a quality of the language. What does delegation mean? Since it's not super familiar to you guys, think of a real-world example, right? Your parents might say, "Hey, go and mow the lawn." So maybe they're responsible for keeping the lawn mowed in their kind of anal neighborhood, but you are going to do the job, right? So one person is responsible for having something fulfilled, and the other, the delegate, actually does the thing for the person that needs it done. Or I've got a manager and an employee. The manager needs to make sure that a quarterly number is reached, and he reaches out to his employees to actually do that work. So the way that this works in programming means that you've got one class typically, or one type that needs a task done, but doesn't implement it themselves, and then you've got another type, and that is the delegate, that actually does the work and that signs up to be the delegate to do that job. Now you might say, why is this coming right after protocols? Well, surprise, surprise. The way that this negotiation of, hey, do you want to be my delegate? How that happens is by the delegate fulfilling a protocol. Right? And so the protocol usually encodes exactly the requirements that the delegate needs to fulfill to be the delegate for that other type. You will actually most often find yourself, sorry to say that, in the role of the delegate. Right? When you use the UIKit framework, you will often find there is a class, for example, UI text field. Right? It's a text field that users can enter text into. UI text field provides a delegate, lets you conform to the delegate protocol, UI text field delegate protocol, in order to be the class that, for example, validates text input. Right? So if you have a text field that the user enters text into, and you need to validate that, for example, it only contains, I don't know, digits and no letters or something like this, right? Then you could sign up to be the text field delegate for that UI text field. And sure enough, when the user has entered numbers in there, you will get called to verify whether everything is correct in this case. So you will often find yourself in the role of implementing the delegate for a class from the framework, because that's how a lot of the logic in the framework works, how you use the many of the classes. Another example, the table view, for example, also has something like that. In a table view, for example, you could you could sign yourself up to be the UI table view delegate, which then means that you will get called, for example, when a row gets tapped on by the user, right? To react to that, which may be important. It's probably something you want to do if the user taps on a row, and you do that in the delegate class for that table view. This example here is actually a little bit of an advanced technique that, however, we do see quite often. So we have our view controller that is controlling, probably some table view, right? That's my view controller, subclass from UI view controller, and I am saying I'm not just the the view controller for the table view. I am actually also the UI table view delegate that I just mentioned, and for good measure, I'm fulfilling another protocol, UI table view data source. Both of these mean that my view controller, this class here, is actually going to be responsible for providing data to the table view. Whenever the table view wants to show something on screen, it will ask the data source to provide that data. And the delegate will be the class that will get called whenever something happens to the table view, like data gets changed by the user taps on something, resizes a column, whatnot. In all those cases, your view controller will then be the class that will then be the instance that gets that's called by the table view object in order to handle this. All right, we're almost at the end here. Final part is extensions. Extensions is actually also covered in book 2 if you want to read along around page 330 if you're looking for it. It's a little difficult to navigate the books sometimes because they're fancy Apple books with lots of interactive features in there. Extensions are, now this is something you may not know from other languages. It was around in Objective-C for those of you who've ever done Objective-C, but Java, for example, I don't think Java has that feature, at least I'm not aware. Maybe they've added it recently. Extension is a way to add functionality to a type that's already there. I mean, how do you usually add functionality to a type, like a class? I've got a class, and you want to add some functionality to it. What do? You subclass, exactly, right? Now, but if you want to actually add, you cannot add something to the class, right? You can only add something to the subclass. You can add a new method or something like that. And extensions are a way to actually add functionality to types as they are there without having access to it. Because the other way to change a type is to go in and literally change the source code that defines the type. Right? But guess what? Apple is not giving you the source code to their string class, right? So how do you do it that you can actually add a method to the string class, not to a subclass of string that you define yourself, that's easy, but to the string class itself. That's what extensions let you do. With extensions, you can add something like new computed properties. Note, I'm not saying properties here, because we're not increasing the footprint of storage needed for an object of that class, right? We're not adding to the properties. But we can add a computed property because that doesn't actually take up space with every instance. It's just a method that gets called that computes the value, right? So we can add methods via extensions. We can provide new initializers, and we can even make an existing type conform to adhere to conform to a new protocol that we have. So this is a very powerful language feature because you don't have to go in. Let's say, here's an example of this. Extensions basically are written in extension, and then you give it some kind of, you have some kind of existing type that you want to extend, and then you just say what needs to get added. So here, we're extending the existing class UI color with a new computed property that is basically just a, the favorite color, right? That goes in. So what that means is, if you wanted this favorite color feature to be available in the UI color class, you don't have to subclass UI color and go through all your code and change everything to my UI color, the new subclass that you created. No, you can just leave everything as is. You add this extension, and all the UI color objects that get instantiated in your code have that new feature. This is pretty awesome. So here's an example of actually using an extension to make an existing class adhere to a new protocol, right? So this was the solution that we had, right? We had struct employee equatable. That's how we did it. But that required us to change the employee, right? And you may have heard about the fragile base class problem and these kinds of things. Whenever you do something like that, you have to change that class. You need to recompile all the code that uses that class, right? So if instead I have no access to that class, maybe it's defined by somebody else, by Apple or whatever, I can write this extension and say, I want employee also to conform to equatable, and I'm providing the function that is necessary to fulfill that protocol. And all of a sudden, all the employee instances that are used in your code can do this. You can even add a new initializer, as I just said. Why would you want to do this? Let's say you've got the string class and you want to add a new function to initialize a string with a bunch of characters, but you want that initialization to check whether those bunches of characters are a good password. You could do that. You could make the standard string class in iOS actually support that with a new initializer that's called maybe, I don't know, initialize with password or something, and it could have all the sanity checks in there that you want. And from then on, all your existing code that uses string could just use this new functionality. All right, we're wrapping up. We talked about the app and view controller lifecycle today. You saw a wonderful demo on auto layout, and we introduced protocols and extensions as language features. And as you can see, we also talked about delegates. That's, I think, also an important one. You can see there are language features, there are design patterns. All of these make up a certain sort of ecosystem in which you are developing. Now, the good news is, next Tuesday is a holiday, right? And so we're not going to do class on Tuesday, obviously, but we're also not going to do a class on Monday. So what that means, more time for you to catch up on reading. Do get that ebook out if there's anything in here that you want to maybe read a little bit more about. And also do some coding. Sit down and try out these things. Just fire up a playground, play around and see like, oh, can I actually like do a protocol with an enum? What does that mean? Does it work, or does the compiler say it's not possible? Find out things, explore the code, because the only way you learn coding is by coding. So next topics after this short mini break then is going to be scroll views and table views. Thanks everybody, and see you soon.
This content was provided by RWTH Aachen University.